Have you ever thought about traveling to a distant galaxy? With the current technology, it might take millions of years to reach there. Is there any shortcut to travel through the interstellar regions? A wormhole is an ideal shortcut for intergalactic traveling. It connects two faraway points in space-time through a tunnel or bridge. The bridge's length is predicted to be far shorter than the distance between the given 2 points. So the tunnel acts as a shortcut. The wormhole concept is one of the many path-breaking predictions of Einstein's general relativity. What is a wormhole? A wormhole is an intergalactic structure connecting distant points in space-time. It is also called Einstein-Rosen bridge. The entire idea is constructed on some special results of general relativity field equations. In 1957, physicist John Archibald Wheeler introduced the name wormhole. It can be picturized as a tunnel or bridge with two ends at different points in space-time. It might be separate points in location or time. Wormholes are fundamentally based on the general theory of relativity. However, physical existence is not yet confirmed. There is a possibility that wormholes are just complex projections of a 4D space-time fabric. Hypothetically, a wormhole could bridge extremely long distances like millions of light years. In extreme scenarios, it might even be able to connect parallel universes if they exist. Mathematician Matt Visser stated there could be numerous wormholes if cosmic strings with negative mass were produced early in the universe. Kip Thorne and Frank Tipler put forward the idea of artificial wormholes. The possibility of time travel and teleportation could be vividly explored through these high-concept hypothetical objects. Physicist Ludwig Flamm came up with a new idea while analyzing some solutions to the equations of general relativity. He proposed another unique solution, which pointed to a new cosmic object called white hole. It was nothing but a hypothetical time reversal of a conventional black hole. Access to both white and black holes could be joined by a space-time tunnel. Supermassive objects like black holes and neutron stars warp time and space. When such warping goes to another level, the physics of space-time also changes drastically. In 1935, Albert Einstein and Nathan Rosen extended general relativity to expand the above idea. They proposed the existence of tunnels or bridges through the space-time fabric. These tunnels could join two distant points in the universe, thus creating a weird shortcut that could minimize distance and travel time. Later they were named wormholes or Einstein-Rosen bridges. Wormholes have two openings and a tunnel connecting these entry points. Each spheroidal opening probably contains supermassive objects that could warp space and time. The bridge or tunnel might be twisted or straight, depending on the inherent variables. Most of these are mathematical assumptions. Theory of general relativity theoretically forecasted the presence of wormholes, but there is still no physical evidence of wormholes. It is interesting to note that some special solutions of general relativity permit the possibility of wormholes with black holes at each end. On the other hand, there is significantly less chance for normal black holes to exist as part of wormholes. Consider space as a two-dimensional plane or surface. Then a wormhole could be considered a hole in that plane. The hole will lead to a three-dimensional tube, which in turn connects to another 2D plane mentioned above. It will re-emerge as a hole identical to the other side. In reality, a wormhole should have holes that are projected on a three-dimensional space. The most effective way to picturize wormholes is by using paper sheets. Consider the sheet as a plane in the space-time fabric. Draw 2 points on the sheet, with considerable distance between them. The 2 points mark the distance to be covered or traveled. When we fold the paper, the distance between the points will dramatically decrease. Just like this example, a wormhole warps or bends space and time, reducing the disparity between two given points of space or time. Albert Einstein understood that there were huge consequences with the general theory of relativity. The theory showed that closed time-like curves could exist in the space-time continuum. The understanding of time took a wild turn and obliterated the concept of universal time. In 1969, Kurt Gödel developed a cosmological time travel prototype that allows dynamic time phenomena. However, an enormous amount of energy is required to create time warping or dilation. Wormholes have been the epicenter of conversations about time travel in recent times. With the help of wormholes, there might be a possibility to create practical time machines. Wormholes are space-time planes with non-trivial geometry, connecting distant points in the universe. Such portals may act as spatial shortcuts and can also be used for time travel. Let's go through the current status of wormholes. Science fiction is loaded with stories of traveling using wormholes. Unfortunately, when it comes to our reality, time travel is far more complicated and has too many variables to address. Moreover, we have not yet observed even a single active wormhole. Dimension of wormholes is a major problem. Ancient wormholes are considered to thrive on microscopic levels 10 to 33 cm. Since the beginning of the universe, space-time has been expanding. So there is a possibility that primordial wormholes might also have gotten larger. With the current knowledge, we cannot predict their size and nature. As per theoretical analysis, the Einstein-Rosen bridge is quite unstable. In fact, such wormholes will be useless for spatial or time travel because they can be broken down quickly. For a stabilized wormhole to exist, the constituent matter must be very special to withstand the turbulent conditions.